All right, Monday, June 21st, 2021, Math 3 Spring. A little bit of notes after class from Mr. Turek about domain and range. So I have here a piece of graph paper, and I've taken an arbitrary function, y equals 1/3 times x squared, and I've created a data table to plot some dots to show this curve. So for x-axis, I put -3, -2, -1, 0, 1, 2, 3. I then evaluated y for each one of these values of x. So I plugged in -3 for x, -3 squared is 9, 9 times 1/3 is 3, so the y value is 3. I plugged in x equals -2, -2 squared is 4, 4 times 1/3 is 4/3. I plugged in x equals -1. -1 squared is 1. 1 times 1/3 is 1/3. I plugged in x equals 0. 0 squared is 0. 1/3 times 0 is 0. I plugged in x equals 1 and got y equals 1/3. I plugged in x equals 2 and got y equals 4/3. I plugged in x equals 3 and got y equals 3. And as you can see, I've already plotted the dots, and I can recognize, oh, this is a quadratic formula, ax squared plus 0x plus 0. So when I recognize that it is a polynomial of degree 2, or in other words, a quadratic equation, I know it is the shape of a parabola. I could plot some more dots, but what I have right here is enough to work with at the moment. So here is the bottom part of a parabola. And the question is for this original function, and by the way, instead of writing y, I can just write it as f as a function of x. We can do it that way as well. What is the domain for this? Well, the domain is the span of x values for which a y value can be computed. So for each value that I put here, x equals 0, 1, 2, 3, -1, -2, -3. For every one of those values that I put in for x, I can go ahead and evaluate and get out some value for y. So the domain is 0, and it includes each one of these points that I've done, but in addition, it includes any point in between them. So if I put in x equals 1/2, why, that would be a part of the domain as well. And x equals 2.5. In fact, every single point between the ones I've plotted fits in the domain. Now, there's no reason why the domain stops where I stopped my data table. I set my data table to match the size of my graph paper. But as I look at this function, there's no reason why I can't put in y equals -4 or -5 or any value in between those, and on and on. In fact, there's nothing that stops x from going farther and farther and farther in the negative direction. So I would list the bottom of the domain as being negative infinity. And when there's no definite end to it, we use ordinary parentheses to represent that. Going in the positive direction, I can go beyond x equals 3, x equals 4, 5, 6, 7, 8. I can keep going. In fact, there's nothing stopping me from going all the way to infinity. So when they ask what is the domain of this function, we're not looking for a single number. We're not looking for a point. We are looking for a range. And the domain in this case is open parentheses on the left, negative infinity, comma, positive infinity on the right, close parentheses on the right. That is the domain of this function y equals 1/3 x squared. But along with the domain, we often want to know what is the range. The range is what are all the possible values of y that you can get for all those possible values of x in the domain. As you look at this curve, remember the y-axis is increasing above the origin. The negative y-axis is going down below the origin. And as I study this curve, I see the lowest value of y that I ever encounter is right here at the origin, y equals 0. As I move x to the left towards negative infinity, y increases. It becomes more and more positive. As I move x to the right towards positive infinity, y again increases and becomes ever more positive. Never is there a value of y less than 0. So the range in this situation begins with a value of 0. And that is allowed to be one of the values. So we represent that with a square bracket. As for the upper end, just as my data table only went to 3, that doesn't mean anything that I chose to end my data table at 3. So too, the y values can continue to increase in value, greater and greater and greater in the positive direction, greater and greater and greater still in the positive direction, even when x is in a negative range. So the upper limit for y is infinity. And we would represent the range in this example as being square open bracket 0, comma, infinity, close parentheses. All right, I hope that helps you with the homework.